we might have a multi-layer switch, and a multi-layer switch is able to independently, without relying on a router on a trunk, it can independently route traffic between different VLANs. And the thing about a switch, sort of unlike a router, we might have multiple interfaces, multiple ports that all belong to the same subnet, to the same VLAN. The question is, how do we route traffic between those VLANs? It's not like we go into every interface and say, here's your IP address and here's your IP address. That's the way we do it on a router, but on a router, different ports, different interfaces, they belong to different subnets. But on a switch, we might have a grouping of ports that all belong to the same subnet. How does that work? Well, what we can do is create a switch virtual interface, something called an SVI. Here's the way it works. Let's say that we've got a switch, and I've got some laptops, some PCs that are members of different VLANs. Let's say that these two laptops are members of VLAN 200. These are members of VLAN 100. They're connecting into our switch. How do we route between those? Well, the switch could have a virtual interface, a virtual SVI interface. We could say interface VLAN 100. And then we could have an IP address for that VLAN. We could have an interface VLAN 200. And that virtual, that SVI interface represents all of the ports in that VLAN. And it's responsible for routing to and from that VLAN. What could go wrong? Why might that not work? Well, it could be addressing. This SVI interface, that's the interface to which we assign an IP address, much like we would assign an IP address to a regular router interface. Maybe the VLAN that we specify, when we say interface VLAN 100, maybe it should have been 200. Maybe we specify the incorrect VLAN ID. Maybe that VLAN is not even created. We haven't done that yet. Maybe we've got the VLAN created, but none of the ports that are assigned to that VLAN, none of those ports are in the forwarding state. It's kind of interesting, and we'll talk more about this, but on a router, you do a show interfaces command or a show IP interface brief, and you can see if a physical interface is up. Is it up at layer 1? Is it up at layer 2? In this case, we're talking about an SVI. We're talking about a virtual interface. How do we know? What indicates if it's up at layer 1 or if it's up at layer 2? Well, we have to have at least one port in the forwarding state for this virtual interface to be up. By the way, that interface that is representing VLAN 100, for example, that could be a trunk interface. If that trunk is carrying traffic for VLAN 100, that would be enough to have the SVI for interface VLAN 100 to be in the up state. Or remember, just like a regular physical interface could be administratively shut down, we can have an SVI that's shut down as well.